Intermediate Algebra Section 11.1. In this video, we're going to take a look at writing sigma notation for a given sum. We have four terms that we're adding together here. We want to compress this into our shorthand of our sigma notation, so we'll use the Greek letter, the uppercase sigma, to represent the sum or the addition of these numbers. We need to write our index, and we can use whatever variable that we want. There's no rule that we have to start at 1, but to help us see a pattern here, this is our first, second, third, and fourth term. And if we look at the denominator, those match exactly. The numerator is just one more. So to come up with a rule or a notation for this series, we can use our index notation. And again, the variable isn't standard either. We can use K, we can use N, whatever letter that you want. Always starting with the starting point, and it, as I said, doesn't always have to start with 1. In this case, that's the easy route, and we do have 4, so we indicate the top of this finite series here. And what's the rule then for this? We have a denominator of n for each one of these, n to 1, 2, 3, 4, and in the numerator it is one more than our term number. And I guess since I used a k, I better be using a k here in my rule as well, just so that they are similar to one another. If you're using a k, put a k in your sigma notation as well. And I would test this to make sure that this does generate out the expanded series that we have here. In this next example, we're asked to find this infinite series of this sequence. So we're headed towards an undetermined or infinite number of terms. So for our sigma notation, this is going to go to infinity. Where we start is totally up to the individual. We have alternating signs, so we have to deal with the fact that we must have a negative number here that's going to be taken to a power so that we get that alternating positive, negative power. There's, as I said, a couple approaches, and just to illustrate, maybe starting at 0 and first and second and third term, simply because if you look at this series, each one of these is 10 more than the other, plus we have the alternating positive, negative signs. So anything to the 0 power is 1. Here we have something to the first power, so if we do a little thinking about this, what's the possibility that our base is negative 10 raised to the 0 power would give us 1. Negative 10 to the first power is negative 10. Negative 10 to the second power, a negative times a negative is positive, that works. And if we have negative 10 to the third power, 3 negatives result in a negative, and 10 to the third power is 1,000. So here we're starting at a k of 0, and it works out that the rule then is negative 10 to the k power. Now, if someone else had decided instead to go with first, second, third, and fourth terms, then our summation would have started with k equals 1 to infinity because of this ellipsis, and to counter for that alternating negative sign, perhaps if we took negative 10 still as our base because of the relationship between these terms in this series, but if we have a k minus 1, would have given us 1 minus 1 for our first term, or to the 0 power, negative 10 to the 0 power would have given us a 1. And so on. If you test the rest of the values, it'll generate this list. So there is no hard, fast rule. The key is make sure your solution does generate the series that's given.